Hi, okay, so today we're going to be talking about similar triangles. So when I talk about similar triangles, I'm talking about triangles of three types. The first type is triangles where this is theta, this is alpha, and this is beta. Now these are just names, you can call them whatever you want, you can call them X, Y, Z, it's just different names. So if we have that triangle, let's call it A, and with triangle B we also have a theta, alpha, and beta, so those corresponding angles are equal, then we call these shapes similar. Now, just to emphasize, the reason they're similar in this case is because this theta is equal to that theta, alpha is equal to alpha, and beta is equal to beta. Here's a solid example to give you an idea. Alright, so here's what it looks like in practice. So, we have, in this case, 50 degrees in one corner, 60 degrees in another corner, and then we have 70 degrees in the last corner. So we can kind of attach an equal angle to each of the angles in the triangle, and that's what makes them similar. So that's what we call corresponding angles being equal. The next one we're going to look at is when the interior ratios, wow, that's a mouthful, interior ratios are equal. So let's look at this side quickly, AB. So if AB divided by this side over here, BC, is equal to DE on the other triangle divided by, let's say, EF, then we can see that these two triangles will be similar again. So, for example, if this was 1 and this was 2, then AB would just be 1 over 2. So we would just write that here. And then if we were to use 2 and 4 here, we have that DE is nothing but DE over EF is nothing but 2 over 4, and that is going to be 1 over 2 if you simplify it down. So because those ratios are equal, we say that they're similar triangles. Now, we could have easily just done the same thing on this side. We could have done perhaps, if we said that AB over AC is equal to DE over DF, we prove the same thing. So you can take any two sides, and if you can show that the ratios are equal, then you're fine, you sort it. So in this case, if that was 3 and that was 6, we would get 1 over 3 and 2 over 6, and those two are equal, because when you simplify that down, that becomes 1 over 3. And that's the second case that, I should have changed this to a 2. This is the second case for which, well, not working out here. This is the second case for which similar triangles can be proven. Alright, so this time I remembered to change the number. So let's look at this case. The last case is when the corresponding ratios are equal. So for this one, we have a look at one side on the first triangle, and we link it to another side in the other triangle. So let's say AB and DE. If we can show that that is equal to another pair over each other, so let's say BC over EF, and for the other one, for the last side as well, so here it'll be AC divided by DF. If we can show that, then we will have shown that the triangles are similar. So basically, you want to link this side to that side, the side to that side, and the side to that side. And if you can show that the ratios between each of those sides are equal, then those triangles will be similar. Alright, here's a question, and this is a way that a similarity question can be asked. So have a look at triangle A and triangle B, and try to figure out if you think that these two triangles are going to be similar. Okay, so pause the video while I attempt it. So, in this case, we got to think, what are the three ways we can prove similarity? We can do it with corresponding angles, interior ratios, or corresponding ratios. In this case, we're given angles, so let's use the angles, right? So, but the problem is that we have these two angles in this triangle, and we only have this angle in the second triangle. So it's a bit difficult because we can see that those are clearly not equal. So what I recommend for this is try to fill in as much information about the triangles as you can. So for example, we know that the interior angles of a triangle will add up to 180 degrees. So here, let's call this angle x. X plus 50 degrees plus 50 degrees must be 180 degrees because the interior angles of a triangle must add up to 180. So x plus 100 degrees will be 180 degrees. So x is equal to 80 degrees. Okay, so now we're on a good track. So we can just fill in 80 degrees there for x. Okay, and then what we can do is we can do a similar thing for the other triangle. No pun intended. So for this triangle, we can see that this side is equal to that side, which means it's an isosceles triangle. And because it's an isosceles triangle, let's call this y and this y. So those two angles will be equal because it's an isosceles triangle. So in this case, we have 80 degrees plus y is equal to 180 degrees. So 80 degrees plus 2y equals 180. So then 2y is equal to 100 degrees, and y is equal to 50 degrees. Okay, so now we've got that this is going to be 50, and this is going to be 50. And now we can see that all of the angles in the triangles are equal, so these two triangles are similar. So we can say here, yes, they are. Right, so let's try this question over here. So in this case, are these two triangles going to be similar? And I would like you, again, to pause the video and try it yourself. But remember that we want to think, what strategy are we going to use? So we can't use the first proof because we don't have any angles here. So we're going to have to use either the second or the third method. So we can either show that AB over BC is equal to DE over EF, or we can show that AB over DE is equal to BC over EF is equal to AC over DF. Okay, so those are the two options that we have. We can prove either one of those two things. And so it's up to you. You can actually choose which one you want to go with. I'm going to go with the first one because it just seems like it's less work. So I'm going to go with that one. Right, so what is AB over BC? That's going to be 5 over 3. Okay, so AB over BC is 5 over 3. DE over EF is going to be 2.5 over 1.5. Now, two options here. Either one, you can put this in your calculator and check, or two, you can turn these into fractions and then you can simplify. So 2.5 is just 5 over 2, and 1.5 is just 3 over 2. And then those will cancel, and we get 5 over 3. And that's clearly equal to 5 over 3, so those two triangles are going to be similar.